Suresh and Subhaya and my dear friends. I'm indeed very thankful for the Madras Management Association for giving this opportunity to talk to you. Of course, I am a stranger to management. As you would have probably guessed, I have spent almost all my life in ISRO, and the last few years have been with a sort of a startup. I will explain what is the task which we are doing. Today's theme, as you know, is technology for development. And my intention is to highlight what, in my view, which I strongly felt through my experience both at ISRO and with the Team Indus, how this country can develop. Of course, everybody will have different interpretations of what is development. I do not know. Having digital connections and digital accounts and internet banking is an important development, but if you don't have money in the bank, it is of no use. So like this, there are different interpretations. The only interpretation which I have is that the country should be happy, and for that you need to be prosperous. So you need to generate wealth. And everyone should participate and should be part of this generation of wealth and happiness. And it cannot be isolated and it cannot be otherwise cannot be called development. So my talk is in this direction. So, and it is very clear that technology is the only way for rapid development of India. And what I wanted to show and tell is that one way of developing India to be prosperous and happy is to use what I call a new generation of technology, high technology enterprises that is driven by very young, daring, passionate technologists. And this I have seen from the example of Team Indus, which I will explain. If you can multiply this, encourage them, and then this country can indeed progress and be in par with the rest of the world, the developed world. This is what the total message which I wanted to try and convey. So Team Indus, which I want to explain as an example of this new generation of enterprises driven by young, daring, passionate technologists, is doing some work which I will explain, and then you can see whether that can be a model for the country's development, at least influence the country's development. Team Indus was started on a challenge for lunar exploration mission, and this I will explain in detail. In fact, I have a small video clip which will introduce how it started, very, very, very short. And of course, we have many things to be done for development, for advancement of the country. Digital technology, as you know, is making very many positive changes in our lives, very positive changes. And they say the new oil is data. So the big data and related developments, whether it is machine learning, whether it is analytics, whether it is artificial intelligence and several other new technologies using data, is increasing the power, spread, and speed of this impact of this digital technology. And of course, I strongly believe just the government or a few big private enterprises alone cannot transform this country as diverse, as big as India. And it is required to have a large number of high technology enterprises led by, again, the new generation of young technologists to really make an impact. So Now, this is, I will now introduce Team Indus. Before I get into
we leave as we came, and God willing, as we shall return.
These people are trying to demystify this entire concept of a lunar exploration. I think this is exceptional.
We're doing the aerospace solution, which hopefully is going to land on the moon soon.
I think we ran out of doing crazy stuff on planet Earth, so that's the next phase to go.
Everyone here realizes it, that you're making history. And I think that's what drives people the most.
We have the talent, we have the caliber, we have the initiative, and we have the motivation. Let's compete at the world and see if we can win.
And I think when they win, India wins.
Okay, so you saw a glimpse of how Team Indus started. You were initially seeing Dr. Kasturi Rangan sort of appreciating this start in the what happened? Yeah, so Team Indus is actually flying a privately funded spacecraft to the moon. And this is a new spacecraft company. In fact, this is the only private enterprise, you can say even in the whole world, who is concentrating on this platform for lunar exploration. Of course, they have several other ambitions and all that. And it is, of course, the only company in India. A private company. And there are many specialities, and this team called Team Indus actually is consisting of very young, very enthusiastic, passionate technologists, the large number driven by them. But as you know, inexperienced youngsters, enthusiasm alone cannot take you far. So they have very carefully designed, they have captured the experience of several hundreds of years of technology in India, in ISRO, for example, and integrated all retired people. Of course, the working people will not come. Like me, I am the oldest in Team Indus right now, actually. So they have captured the experience, the learning, some things you have to learn from past experience, some things you have to unlearn. That means you should not repeat what you have done because you know that should not be done. So from both these points of view, it is not only managers and big people, but even the technicians. In fact, it is very important to capture what we know from the level of technicians to the highest scientists and technologists. So this has been achieved as a small number of experience integration into this youngster-driven 100-team is what is Team Indus. Actually, it was started as a team for competing in the Google X Prize competition. In fact, they were on the top of the world of all the teams. They won some prizes and so on. Of course, Google X Prize is not now there. And they have, as it is required, they have interaction with many in the world, whether it's this French Space Agency, whether it is US universities, in India, many enterprises who is good at whatever they are doing. So this kind of a partnership, Hakuto in Japan, and several other units, because you cannot work in this new world and high technology in isolation. It is impossible. So you have to be partnering, participating, and interacting with the rest of the world, institutions, universities, and so on. So this team is very typical and very unique, and that is what is required to handle such high technology projects like the moon mission. Now, just to explain the mission 1, because there is a series of missions online positioned for the future. The first mission, for example, contains development of a lander. Actually, we have already developed and qualified the lander, which is a very lightweight satellite, which will go all the way to Earth orbit, to the moon orbit, and then land very softly, because it is the soft landing with impact energy absorption, all that is important. So the one thing is the actual satellite, and that contains a lot of payloads like rovers. We have built our own rover, what is called ECA, Ek Chote Si Asha, and it's about a micro, semi-autonomous, unique system. It is an all-terrain vehicle, four-wheeled. I will get you some more details. And it is a very efficient one with a lot of experiments, including a robotic arm and cameras, high-definition image processing, all that kind of things for terrain, avoidance of obstacles, and so on and all that. And we have other experiments like orbiting satellite. We can launch a small satellite around the moon when the main one lands. So we can have other rovers. For example, the Japanese Hakuto company is flying a rover on this one. They want to do exploration of their own, and several such payloads, which I will show you later. Of course, the launch is done by the launch vehicle available commercially. It could be ISRO's, it could be SpaceX, it could be Russian, it could be European or anything. So the design is universal. Now, this is the mission, just to give you a familiarity. We go around the Earth into a lunar transfer trajectory, which is very elliptical. These days, the launchers are able to put you there. And from there on, you get into the lunar trajectory. After a few orbits, you get into a very circular 100-kilometer orbit, and then you fire your, of course, even for this, you need to fire your own engines and so on, and you sort of break yourselves and land on the moon surface, wherever you want. And there are a lot of energy absorption and such requirements are there. So you do a landing, very precise and very smooth on the moon. So right now, we have this sort of a 20-day mission to reach moon, because it's more than 4 lakh kilometers. So, and then the life of this mission currently is 1 lunar day, which is 14 Earth days, because the night survival right now with the current technology is very difficult. Nobody has survived without this isotope or nuclear-based heating and so on. Even ISRO's missions and several other missions are, the lifetime is 1 day, because 1 day means 14 Earth days on the moon, because the nights are very cold and normally batteries don't survive. So unless you have an extra heating device and so on. So this is the sort of mission. And now what are the technologies and which will help develop the country into an advanced nation? Now, what are the things being done in this project which will help in general? First of all, a lot of disciplines. It is actually multidiscipline. And there are many things which you can see, whether it is related to systems, subsystems, which is being done, which are all state of art. State of art means it is as good as anybody in the world. And we need to push the boundary of our technology to make it better and better. So this is the first thing, whether it is structures, whether it is autonomous operations, communications, or avionics, or whatever, propulsion, or any areas. We need to push the technology to the state of art, master it, and then only use it. So that is itself a big activity, big achievement, which can be used even elsewhere. Now, this also involves optimization of mass, minimizing the mass, minimizing the power, minimizing the time required to develop, and of course, optimizing the efficiency. That means in terms of the performance of systems and in terms of the payload fractions, we have to optimize. And of course, there is always a driving fact of reduction of cost. Because being a small company, being a private entity, you need to reduce the cost and minimize the cost, and then only you will be competitive. So that is one aspect, a second aspect. Now there are the technology-wise, the autonomy is an integral part of this entire operations, because you cannot, there is of course time difference because of the large distances for communication. Apart from that, many of these operations, because man is not present, it has to be autonomous. So you know the autonomous operations requires a large technology, proving, simulation, and so on. And it has to be done all in remote mode. And we need to survive under very harsh environment and in harsh terrains. A harsh environment means, just to say an example, on the moon you have heat intensity of 2 suns. Of course, the heating from the moon, not on the surface is much more than 2 suns. Even at 100-kilometer orbit around the moon, you get heat effectively from 2 suns. One is from the sun, directly from the sun. The moon is also as hot as the sun at 100 kilometers. So you have to handle 2 suns when you are at 100 kilometers. And you can imagine when you are on the moon, it is terribly hot because the moon is very hot. Moon temperature is around 110 degrees if you touch. And then you are getting solar radiation also. So you have to handle this kind of heat. And then, of course, you have terrain, ups and downs, and small rocks, and so on, and all that. So all this we will have to handle. So our rover is an all-terrain vehicle. In this case, of course, it's a micro rover, 4-wheeled, very small weight, and so on. Even the landing, we have to take care of these things. So it is entirely solar-powered, as you know. Coming to the system level, the Team Indus has to develop the spacecraft, the main lander, and small orbiters for experimentation. And then rovers are there. One rover, which I mentioned, ECA, and that has many technologies, including the soil testing, cameras with the pan and tilt, highest technology to reduce weight, advanced carbon fibers, and so many things, of course, is used. Then we have several science and technology experiments, both on the rover as well as on the lander, which I will briefly explain. Now, the moon landing and the lunar rover mission planning, design, simulation, execution is indeed by itself a great task because you have to simulate the gravity fields of the moon, earth, and other influences, the radiation, solar, even the other radiations from the sun, because it can damage electronics and processors and so on. So all this needs to be done, simulated, and make sure reliability exists. And the integration of the entire system of satellites and rovers and all that technology and testing. There are several tests to be done on the Earth to simulate the launch, simulate the orbit, simulate the landing impact, and simulate the thermal conditions and so on. So all these tests has to be done on the Earth before you actually launch. So all this together really is a collection of the disciplines of all branches of engineering, testing, analysis, simulation, and all that. So this can really kickstart a large number of developments in a large number of fields. In fact, after Team Indus started, from Team Indus, at least half a dozen startups have started, actually, because they get inspired. If this impossible thing can be done by this team, why not me do something smaller, at least? So this is really an instigator or incubator of startups for youngsters, actually. So this has also happened. Now, just to show you, this is a typical diagram of the lander satellite. What you see, these flat surfaces are actually solar panels. It's not a photograph, it's a CAD diagram. Actually, it is built, qualified for vibration and loadings and all that. Even landing we have dropped and simulated, and it is all qualified, actually, this part of the structure. So it is a very highly scalable, robust architecture, catering different landing missions and, of course, payloads. It is using very light, ultra-light lander structure, which is using not the normal carbon fiber, actually very advanced carbon fiber construction sandwich, not normal solid construction. And we have designed and incorporated very special energy-absorbing devices into the landing gear, because it is very critical. If you have a rigid structure, if it falls, it will damage all the electronics and systems and so on. So special devices have been incorporated. We have advanced guidance, navigation, and control hardware for the descent particularly. We have electronics and power systems, and of course multiple rovers, our own as well as commercial, other people who want to fly, orbiters for experimentation, and other many science and technology experiments. So this is just views of the same lander. And the one important payload I mentioned is the rover, exploration rover we call it. It is very special compared to many rovers many people have built and flown, and even taken to moon also and Mars. So this is a very simple, small, mini rover, four-wheeled. It is autonomous, semi-autonomous, because we may need to do some operations there. It is all-terrain, and because there are many unpredictable things, and we have image processing which can avoid real big obstacles. So it is using many materials, aluminum, titanium, CFRP and so on, because that is what is required to make it weight efficient, totally solar powered, with several other sensors and cameras and so on. And the Team Indus has interacted with a lot of scientific communities, colleges, and nationally and internationally. And that has brought in a lot of experiments. One, of course, is from the Japanese, the rover. They are flying for around 5 kg mass, a rover, their own rover, for their own exploration on the moon. Of course, it is a commercial requirement. They pay, and that is one payload, actually, is part of this. And there are CNES, that is the French Space Agency, is flying their own newly developed cameras on our rover, so that they can do the image processing. They are first time experimenting with such a high definition camera. And there are several other scientific payloads in collaboration with research institutions, government and private, in India and abroad, which I will briefly show you a few. And then there has been interaction with a lot of students, because that is, see, you have to be part of the society to be really making an impact, and you can also get inspired. And they have floated a global competition, or sort of a request for experiments. So there were almost 3,000 entries from 9,000 students, and it was shortlisted to 25, and then 6 students' experiments are actually finally selected to fly on board this lunar mission. And so this is a sort of a first time such experiments are being flown after so many years, and this information will be open to all. That is the understanding. So there are several experiments, and I'm just showing some of the experiments from various agencies. Of course, some is sponsored by agencies like Biocon and a few other institutions, some from abroad, some from India itself. It all addresses different aspects of technology and science. In fact, some biological experiments like bacteria growth and such things under the protected environment, even that, all that is there in small, separate autonomous canisters. Now, in fact, as part of the outreach program to reach the students and young generation of India, in fact, the Team Indus has, as part of its outreach activities, made a bus with some of these items and displays and information to go all around India. And they have, in fact, already traveled 12,500 kilometers across India, 20 regions and 11 states, and 42,000 more plus children have reached and interacted with this particular display. So it is the intention is to popularize this, demystify the so-called space technology and going to space, because it is accessible to everyone and they can aspire to do, of course they can aspire to go to space also, and this was the intention, and this is the intention of the original Google X Prize also. So the Team Indus, though it's a small 100-team team and it is a private enterprise, they are trying to make an impact in the country and to take the country to the leading edge of the advancement in this area of technology. And I hope multiplying this kind of enterprises in India will really take India to the forward, to the developed world. But while saying all this, I should also point out there are certain limiting factors in this, particularly in India, on Team Indus type enterprises making an impact, big impact. So I just wanted to point it out because that is also important. One problem with this kind of enterprises is the limiting factor is the availability of infrastructure requirements, particularly. Because, space, for example, all facilities required for space qualification is available only in ISRO now, in India. And of course, it is not realistic to expect ISRO to provide you all that you want if you have particularly more people. And it will be very costly also, not affordable. So there are requirements to have infrastructure requirements, particularly certain infrastructure requirements. If it's a large material processing autoclave, for example. Of course, government is having some plans to have common facilities in different regions to be open to all private enterprises and entrepreneurs and all that. So, and the other problem is availability of critical materials, particularly advanced materials. If you go and ask for a buying, they will ask minimum quantities, for example, and minimum time. So, for example, the whole satellite weight may be a few hundred kgs, and the requirement for an adhesive or a special composite may be a few kgs. And you will have to buy minimum hundreds of kgs, and it will have shelf life, it will have several other problems and so on. So this is another big problem. Of course, maybe enterprises can join together or tie up with the suppliers, and there has to be remedies. Of course, Team Indus has overcome in different ways, but I think these are limiting factors. So availability of critical advanced materials in required quantities is a big problem. Advanced processing facilities and precision manufacturing and inspection facilities. You can, because one cannot build. You would have heard Elon Musk telling SpaceX is doing 80% of all that rocket work in-house under his roof.